Hi, we're Group Hamar Saeed, and we have picked out a couple of assorted problems from Well Logging Lab 6, which we will be walking through and then discussing the industry application of the lab as a whole.
Well, I'm Hassan Ismail. I'm gonna do 1G.
And my name is Dania Abu Humayl. I'll be doing question 3A.
My name is Brett Allison. I'll be discussing the industry application of this lab.
My name is Logan Mullen, and I'll be going over problem 1F.
My name is Jared Cooper, and I'll be discussing problem 3B.
Problem 1F asks, how does changing porosity affect calculating water saturation? As you can see from Archie's equation, porosity affects water saturation inversely because it's on the bottom of the equation. Increasing porosity will decrease water saturation, and vice versa.
Well, the question says that how and why does the RT varies with the water saturation. So, first of all, the water saturation is fairly low, and as the whole formation increases, this indicates that there is less water, so less water saturation. So, water saturation and the formation resistivity varies inversely.
Alright, so question 3A was asking about a lead engineer that assumed a wrong lithology of limestone, and so he got the wrong net recoverable value. And the question is asking for the change in price that needs to increase so that we get the same net recoverable value. So what we do here is that we assume the same net recoverable value for limestone, but we put in the EUR, the estimated ultimate recovery, for sandstone. And after we plug into this equation, we get the price of oil, and then we just subtract this, which is 57.55, and we subtract 50 from that, and we get 7.55, and that's about it.
Question 3B asks what parameter used in the OOIP calculation was most affected by the wrong lithology assumption. The wrong lithology assumption affects primarily the porosity of the reservoir, which then, due to Archie's equation, changes the water saturation calculation. The different values for these parameters within the reservoir greatly changes the calculated OOIP calculation. The porosity of the formation changes roughly 9 to 11% in this example when you assume a limestone lithology instead of sandstone lithology.
Hello. So as you can tell, assuming the improper densities and the improper lithologies within a reservoir can have a huge impact on calculating not only your water saturation within the reservoir, the OOIP calculation, the EUR calculation, and in general just the total amount of money your country could have in your company could have in capital as that is unrecoverable and untapped from underground. Assuming limestone over, say, sandstone, for example, it will give you a wrong bulk density matrix for that formation, which will change your neutron and dphi log calculations. This can have a huge impact on your effective porosity calculations, which is then used in your water saturation equation within Archie's, which has an inverse effect as previously described. These changes within the water saturation equation and the porosity will have a double effect as it plays into the OOIP calculation. The OOIP calculation uses both of these parameters within it. So any difference within these two will play a huge role in calculating the total amount of oil that is untapped within that reservoir. This, when plugged into the EUR calculation, will tell you exactly how much oil your company has that has been untapped within that reservoir and that formation. So, if you have the wrong value, it can have a huge impact in determining your total volume that your company can have accessible. This EUR then tells you how much money that reservoir and that formation is worth. So, if you have any type of differential across these, it can cost your company huge amounts of money, huge millions, billions of dollars. Oh, I'm sorry, pounds. No, you're American, so we can go with dollars. So, if you tap into this and you use this information exquisitely and perfectly, you will make your company much more accurate amount of money and have much less percent error. And at the end, it'll become your cup of tea. Hello.